lot of experience with projects. We started in Python, and after it went beyond like 1,000 lines of code, we can't understand what it does. And each time we return to this project, we need to fully read all the code to understand how to improve it, how to fix it. And debugging time depends on your tooling. And in Java or Kotlin or C#, we have a very good tooling support for debug. And I remember in Kotlin, working in Kotlin JS and Kotlin JVM, it's the same language and more or less the same tools for debug. But several times I got stuck with the Chrome debug tools and could not find the bug, and then I just copied this code from Kotlin JS to Kotlin JVM and debugged and found bug in like 2 minutes, because debugging tooling is that much better. And again, the hardware, the computation time is cheap right now, but the development time, the time of your researchers spent on fixing those bugs, is very, very expensive. So do not it's Russian guys probably know those pictures every site. It's a very good cartoon smashariki. It's the language. Do not choose the language because it's fast, because you will just have to toll all this heap of junk after you, but choose it because it's comfortable, because you can make fast programs almost in any language. Okay, I'm close to the conclusion. And I remember the question from Shamsa. I will answer it after conclusion. Some simple takeaways. Think about architecture in advance, separate data and logic. That's a very simple rules for software engineering everywhere. Clean API boundaries, documentation for dummies, not only for yourself, reasonable number of tests, proper build tooling, not only build documentation, and use integration data tests if you are talking about scientific project. What we should not do, you should not abuse object-oriented programming. Actually, if you're writing a simple program, do not in Kotlin, for example. It's not possible in Java to write without classes. In Kotlin, it's possible not to use classes at all. So maybe it's a good idea. I mean, do not use classes with logic, use classes with data. Do not mix different responsibilities in one class or type. Do not invent your own transmission and data protocols. Do not use your object tree as a base for your serialization format. I skipped this point, but maybe we can talk about it later if you want. And do not decide on ecosystem based on the performance considerations. What I said right now is do all good things and do not evil things. They're pretty obvious, but how to decide what is good and what is evil? I think there are some rules here that you can mentally follow in order to build a better software. Do not ever assume that the code is final and never will be used. Again, it could be the case for application, but not ever working for science. Do not ever assume that you will be the only one who using this code. At least you need somebody to reproduce the result you got. Do not ever assume that people will have the same environment you do. Do not ever assume that people will always the same code for the same purpose you do. Again, it's a lot of cases when people started to for one purpose and then use it for completely another purpose. And the final thing is design your code like you design your hardware. So each piece might be standalone, but connections should be standardized. It will help you a lot in the maintenance. So it's the end of, as I said, it's stretched to almost 1.5 hours, and I have to answer the question from Shamsa. Can it be possible? Oops. Can it be possible for industry to collaborate with research scientists to make a source of the code maintainable and producible, etc.? Yeah, this is a great question, and there were actually several attempts to invite programmers from industry to do the research code, and each time it failed. There are two reasons. The main reason is that in order to do research code, for example, if you want to do a physics simulation, you need to understand physics. You can't explain to the programmer who does not know physics how to do physics simulation. You can't even explain, the physicist who is working on the hardware can't even explain to the programmer how to do, how to make a control system, because you need to understand the process. You need to understand how it will be applied. Without it, it won't work. And this is why each time people from the industry came to the science and were invited to do in scientific projects, it ends up with the neural networks. Because you do not need to know a lot about you think you're searching for with neural network. And neural networks are fine, but they do not solve most of cases there are in science. So no, it does not work. It was tried in CERN, it was tried here in Russia multiple times, and I think it was tried everywhere else. The second and the only way to solve this problem is to either to teach scientists to do proper software, which is hard and probably won't work. And as you said, researchers focusing on so many other things, or there should be a separate type of researchers, physicists, programmers, chemists, programmers, biologists, programmers, who can in the same time understand what is happening, how it is done, and understand the software engineering and information technology as a field, a process, how it is done, and could be a medium between programmers and researchers. There is no other way. This is why I believe it is important for some of those people to appear. The second problem is simpler and harder at the same time. Right now, there is a disbalance in salaries between researchers and IT specialists. So you can't expect to pay those programmers 2 times the salary the researcher gets. And it will be inequality. So we are all artists, but those get much more money. It's a problem. And again, I believe that there are ways to combine industry with the research when people from industry work with the researchers and research software part-time. I think it's a good idea because it's a very good experience. So you can create, again, it's artistic. When even software for science, it's a piece of art, and you are becoming better, much better programmer when you try to solve those problems. So it's profitable for industry to ask their people to participate in science for like 20% of their time. And I believe that it is possible in future to make it work. Okay, there was a question, very good question, about what to do with Python. Because indeed, a lot of things are written in Python, and you can't avoid using it in, for example, neural networks. It's actually not quite correct about neural network, because their neural networks nowadays mostly depend on the C frameworks like TensorFlow or PyTorch. and they are starting to do those things in other languages. For example, there are a very nice tool called Kotlin DL. Let me just share a link. Oops, Kotlin DL, and you can try it. But yeah, there are a lot of tools that are available only in, for example, in Python ecosystem. Actually, they're written in C or C++, but it's very hard to interrupt this C or C++, so you have to use a Python. And it is a problematic, and I think in future people will try to migrate from Python. The solution, there are two solutions. The first solution is just to use Python. It's not the end of the world. You can create pretty nice programs in Python, but the second solution is create service. You can create a service in Python and use external protocols to communicate with the software. And I believe that there is no language, at least we do not see a tendency to one language that will solve all the problems. So I think it's more like polyglot environment. So yeah, and the only way to communicate between different high-level languages is to use those web protocols or high-level protocols. I hope I answered your question. There is also an effort from GraalVM team at Oracle to create an environment where you can run both Python, LLVM bytecode, and the Kotlin and the GVM bytecode in the same environment. It's very interesting, but I'm not sure it is what we will do in future, because it will vendor lock on the single platform, and it's probably not good. We shall start in a minute. Probably we can start 10 times past if nobody disagrees. Where is my okay, so let's see. This example here is again, it's a data lore notebook I shared with you, and it's pretty simple. You can probably see it on my screen. Probably, yeah, you probably should. And you can copy this. It's very simple. I've loaded the plotting library. There are two plotting libraries right now for web. It's Let's Plot by JetBrains, and the Plotly kit is written by our team. Plotly is a JavaScript. Let's Plot is a Kotlin first library that allows rendering to the JavaScript environment. And let's just call some cells, and let's see the problem. It's a usual thing you want to do the data. I do not mean data science, but the scientific analysis process is more or less the same everywhere. And let's see the quite typical problem that we want to do. We have a kind of input file. We have a output file, and we need to load data from the input file and do some evaluation and put data to the output file. And let's approach this problem in Kotlin. And I want to show the difference, for example, with Python, or no difference. First of all, I have a function that will generate the input, because I haven't prepared it in advance. So I just create a file and create a random generator and put random numbers from -1 to 1 in each line. And I can see that it's a file, it's attached data, and and we can open it, and we see that input txt here, and we can see that it's just those numbers in a column. Okay, to move it somewhere else. And we can even edit it. So we created this file. We can call this cell, and then we can create this file, and it will be created. Then we have a function that reads the file. It's pretty simple. It's probably even more simple than in Python. If you do not use a dedicated library, in here I do not use anything but plotting library for plots. And I take the file, input file, just create a path. Is one of the ways you interact with files in Java. It's Java neo way of interacting with files. Then I say create the build list is a quite new thing that was introduced in Kotlin standard library not so far ago. We can check the function how it works. Kotlin build list. If I were working in the idea, I would just call inline documentation or fall through with the control click. But since I'm working in notebook, I have to use external documentation. So the build list function just takes a function which have a mutable list as a receiver. So when I call add inside this build list, I'm adding to this receiver function. It's called on the this scope receiver. It's a trademark thing in Kotlin. Probably not available in most of other languages. And it returns a list of items of type E, where E is a type of this thing. And here is an example, for example. Yeah, it's, we create build list. I'm not sure why it's those brackets should not be there. We add one element, then add a list of elements, then add one element again. It's very convenient. And here I take this file, use for each line fun extension. It's an extension from the standard library. We can again call the documentation and search for Kotlin path for each line. And here it is. And it returns a callback function. It consumes a callback function which applied for each line. It's you can call it functional programming, and yeah, it is functional programming, but it's a Kotlin style. It's not exactly Haskell style functional programming. But the idea is that you use a function that takes a function as a parameter. And that for each of those lines, you convert this line to double because it's a string and you need to convert, and otherwise you will have we'll see a compilation error. Let's check. Yeah, there's type mismatch because you want to add a number to this list, and the type is inferred from this type, and you're trying to do string, and it won't work. But now I fix it and it worked. That's all. You create a function, it reads the input, and then you read the input. And then you can, for example, you want to plot the data. In general, I need to use a DSL defined in Plotly Kit to do that. But here I use a shortcut. And here is a shortcut. Let's see. I want just draw all those numbers in the y-axis and with the numbers as x-axis. For that, I need to provide Plotly with just one axis, and here it is. Probably I can move it from here. Let's delete it. And it here. Okay. For some reasons, it's By the way, you see that I changed the cell and it executed automatically. It's called reactive mode. It's a very nice thing, both in Kotlin and in Python. It allows you not to think about the order in which you execute cells. It's always linear. So the shortcut here, it's an extension function. I get this plotly, which is just a namespace object. It's an object, but it's used as a namespace, not to pollute the global namespace, and create a function that takes an iterable and takes additional configuration block here. And this configuration block has a optional parameter, is optional by default. It's an empty function, it does nothing. And then I return this plot, and inside I expand it. I add this scatter, meaning what is the type of the plot. I add those numbers and add configuration. I can also customize it by, for example, adding the name to this plot. It did not help because it's only one plot. It doesn't show the names. Okay. But I can change other things as well, like this. Okay, I can do something else like color. I think I can change color red. Oops. What happens? Not sure what happened. Okay. It's wrong function. I don't remember how it is called. Maybe marker. Yeah, marker, and then that's a color inside marker. Yeah. That's red. Yeah, here we are. So I can both simplify the way I'm plotting data. So I need to pass this part. I do not have to change existing behavior. I need to I need only to add an extension that adds on top of it. This is connected to what I was talking before. That when we are designing software, if we put all functions together once, then we need to think very carefully about how those functions will be used. Will it be convenient? How they will be interact with each other? But if your language allows you to add functionality in this simple way, you do not need to think about it. You just put a bare bones functionality in your software and add everything else later when you need it, when you understand how you will use it. Okay, then, for example, I have a function which smooths this data in place. Probably we will talk about it in the next example. Right now, you can think about why smoothing in place is not a good practice. There's a question. By the way, I do not see chat. Let me open it. Okay. Then, for example, we can do it proper way, the way it is more maintainable, and do not change incoming data. Instead, we take this iterable double as a receiver, and then create a function which returns a new list of double. And using Kotlin standard library, it's like this. So we just create a list of windows, and you can check it with the again help it. It's Kotlin windowed. Here it is, and it creates. You can understand what it does just by looking at types, like Anton said earlier today. It's a list of lists. Each list is a values in a window, and the rest you can understand from the documentation. Of course, always helps if you can do autocomplete. And for this, we write this dot and control space, and we get some delay. We get a list of things you can do with this thing, with this receiver. This is the receiver in this case. Its current scope. And you can see different functions and check the documentation. Of course, if you're working in IDE, right now, this inline help does not work in Datalore or Jupyter Notebook, but I hope it will work soon. And contrary to Python, where you do not have types and you need to check the documentation on each thing, here you just can see if the function with a name similar to what you want to do is there in the scope. Again, it's much easier to understand because and you can do wrong things. You're limited by your type system. So we get this window, and then we get this map reduce. Map reduce is a very important concept of today data manipulation. It's not very convenient to do map reduce in Python because of language limitation, but in Kotlin it's very convenient. I believe that you will have we will have talks later this week about distributed data analysis, and probably they will talk about map reduce. If you do not know what it is, please ask a question. It's very important concept. So, and then we just do like that. And we have a smooth curve. It's like a drunk walk with a less amplitude. Then again, we can add an extension to compute standard deviation. In NumPy, you almost always rely in Python. You almost always rely on NumPy to do this thing for you because it is in NumPy. In Kotlin, you can see that I've created the function that does that in 2 lines. So again, it's a different approach to design. You are not relying on the compatibility with some kind of library. If you want a simple thing, you just implement it, and you are limiting this API boundary size. We talked about it. So there should be API boundary between different libraries, between different pieces of your code. And it is good when the size of this API boundary is smaller, so it's easier to maintain. Oh, then we can just call it with a different smoothing window for this, and we can actually do additional smoothing with a larger window. By default, the window is 5, and here I use non-default window 10. It's even better. Let's see, random walk. We just generated random walk from random numbers. Pretty nice. This technique is actually used when you want to generate a random background. And we can check the statistical hypothesis. For example, we expect that for window number 10, the standard deviation will be square of root times smaller than the smoothing window number 5. It will be correct if all those numbers are independent random variables, random numbers. And you see the result is very similar. Of course, it's not the same because it's still a statistical quantity, but it's very similar. So yeah, let's go. Now we can publish the paper or whatever. But can you say what is the problem here, depending on the lection I told earlier? Maybe somebody can say what are the problems. Oh, okay. First of all, the problem here is that I use fixed input. If I want to use this code, for example, run it several times on several files, I will have to change the input because there will be different input files. If I want to do it, if I will just put this code somewhere, I will need to create this file each time. So probably the good idea is to not hard code the path for this input and to pass it as a parameter. And we can do it here, like path, and let's call it input file. And remove it here. And then in order to read input, we need put it here. See, I haven't changed the code, but I made it more flexible. But I made it more, oops. No. Ah, okay. And here I need input. I need to initialize it. Let's just remove it for now and into the separate cell and comment it out because we don't need it. We already created our input. Okay. What's the problem now? Aha. Yeah. And this one should be commented out as well. Put it here, and this one I need to just to put it here. Now it should work. Okay. I've made my code. What's input file will be empty and the function read input work. No, it won't work. I can check just that. For example, I change the name here and see if the result, and I will get the error. But it's okay. This is actually okay because I will get the error early. If I do not work with some end user application where I need everything to work perfectly, this fine is nice because I have a error early and I do not get the wrong result and I get clear error about that. Because inputs are inputs, we can control them. It's okay. The problem is where you read something and then you don't understand if you read it correctly or not. It's null pointer all again because you don't know if the data exists or it's null. But in this case, it's okay. So my code is more flexible, but at the same time, it's more verbatim. So a lot of words. We want to avoid a lot of words also because, again, the people will read it and if they need to put a lot of parameters, magical constants all the time, it will hard to understand. For that, we can use language. We can use language features like this. We can put this parameter here, and the code will be the same as it was before, but more flexible. So we use the input file. We provide the input parameter, but we provide defaulted. This approach is called convention over configuration. Google it up and you will see a lot of application. It's a very nice concept to use in scientific software. So you are making everything flexible, but at the same time, you always provide, whenever you can, you provide ability to you give reasonable defaults. Of course, you need to write it in the documentation in this case. Then you can provide additional convenience functions. For example, you're not fan of writing path off each time. So what you do is you provide additional API for the end user and say, okay, let's provide a string and convert it to the path afterwards and read and here path of input file name. Yeah, it's exactly the same. So here we can just, for example, since we used the default there, we can avoid using default. There could be a name conflict here. Okay, we can do this way, and this way definitely will work. And it works again. And let's check that the plot is there. It's fine. Again, it's a reactive mode. It means that if I change something there, everything else will be recalculated automatically. Nice. This thing does not introduce additional complexity in our API. Why? Because it does not add additional implementations. It just adds overriding with the different parameter names, and it completely depends on this implementation. It's just a helper function, and it's okay. Of course, there are if you have too many helpers, they just pollute this namespace, and it's also not so good. But in general, it's okay. Now, what other problems do we have? There are problems again with the configuration. I can say the second problem with the configuration. The third problem with the performance, actually performance. The configuration is that we are checking two different types of two different windows, and we need to change our code each time we change the window. Maybe it's not a good idea. Maybe it's a good idea to provide some configurability to this thing. Let's just try to write a sample and then see if it is okay. We can create a function, scan scan smooth with different windows, and here we can take several arguments. We can take argument as a file, path, and also we want to provide different scan windows. Integer, and here in Python we can just start writing function, and we can, for example, write some code here. In statically typed language, we need to think about type, and it's a good thing because when you're thinking about type, you are actually thinking about compatibility. You are thinking about what will be used by the people who are using this function, what they will want in return. For example, we can return a couple of plots to put it directly. Let's do it. Let's not just write it. Plotly plot plot, and then we do scan windows for each. For each is the replacement of for loop. Today in the morning, Anton showed you for loop, how for loop works in Kotlin, but in practice, people rarely use for loop. They use this for each. It's the same thing that iterates all the things in the iterable using its index. And here we will just add plots to this external scope plot. So here we create plot, which has a receiver to which we can add plots, and here we'll use it. Modern Kotlin is very scope based. So you remember not which type you call, but in which scope you call. So let's see this. Scatter. You can see you automatically see this function is available here. Scatter, and we use Y numbers. The data. Oh, we need to read the data. I forgot to read. We need to read the data, but we can read the data inside the scope as well. I don't remember. It's called read input. And we need to use this path with us. And then we say the smooth. Again, I have to complete here, window. And all that left is to put a name. Let's be window. Window, and color is automatic, so it should be okay. And we can call this function, compile, check it's okay, it's okay, and then we can call this function. Stuff. By the way, it already tries to supply the name of the file. Okay. Here we are. You see different windows, and you can see the results are different for 10, for 15, and for 5, and then we can compare them. Okay, we've made a pretty nice visualization with not so many lines of code, and it's flexible. But again, from the terms of point of view of compatibility, what could go wrong here? Do you have some ideas? No ideas. Obviously, how we will use it, how this thing will be used in future. We want to estimate standard deviation, yeah, which means that here, if we make plots, we can't use those plots for estimating the standard deviation. So we need to think in advance about how it will be used. Not only that we create a nice function, but how it will be used. Of course, we can create a completely separate function that reads this standard deviation. But in this case, we work with a small amount of data. But if you work with a huge amount of data, you will have a lot of read duplication and could be expensive. So probably it is a good idea to create an abstraction as intermediate structure that will hold information about what we are doing here. For example, we can create a container for those series, and for that we can use a map. I do not have to create another class, So I think instead of doing this, I can copy it and then I will do the same function, but it will get the map integer list double. Okay. And here I will be using, instead of build map, I will use a build map function, and I will read the thing. And instead of doing scatter plots, I will do put. Again, it's autocomplete, shows me that the put inside this map. I put the window size, and the second thing I put here is a smooth thing, and I get this map. Okay, and now I can do things like more universal way. I can compute the standard deviation for each window. For example, I can do things like, let me comment it out for now. I can do, let me check this compiles, and I can do, for example, compute standard deviation for each of these things. Let us do it. Why it's autocomplete does not work. Now let's here it is. It's already there, so I can just reuse it. And I'm using, and now we see not plot, but the huge map of data. But with it, what I can do with it? I can do, for example, map values, and use two parameters lambda to compute the standard deviation. And I need to move this thing up because I need it before. Let us do that. So up. And then I am, yep. And then the value instead, why it's not available? It should be. Let's check if the types are correct. Yes, it should work. For some reason it does not. Let us check. Let's check. Let's map values. Should work. Yes, I take it. Okay. I need to use destruction here. Okay, and now we are seeing the result of smoothing the window for each of those things. And in case we need to add visualization to this, we can add it later because we already have a structure and we understand that this structure we're using is actually API boundary. It's a type of data structure we are using to communicate between different parts of our code. So now I can, for example, create a function which visualizes this type, like this. Oop. And then I will just copy things from here. And I will paste it here and remove comments and remove anything here. And no, but it's for each, and here we use for each for two parameters like key window div, and everything else should be work fine. And again, I should move it up. That's something wrong. Let me check. Window. Okay. Window. That should work. Okay. And now I can do all things together without writing new code, without writing new, creating new APIs. I can, for example, do it like this. I can add a step here, which will, oops, sorry. No, I can do a step here because it's outputs directly to the cell result, but I can do split this thing in two parts, like while processed data and here I can do process data upload. So you see, this is very simple example, very simple, very obvious example. What I was talking about. When you create this data structure, you will be working with, and then you create your API, which communicates with this data using this data structure from different points. Of course, if you design it wrongly, if you, for example, you will need not only the size of the window, but other configuration parameters as well, you will need to redesign it, changes everywhere. But at least you can change it once, and you know that the resulting types of your data reading will always be the same. The resulting type of your processing always will be the same. And for example, then you can change the implementation of this plotting module without changing everything else. For example, I want to do not scatter, but I want to do a more complicated API here. For example, I can add, I don't remember correctly the plotly API in this regard, but for example, I want to markers, how it's called, this, not type, phrase type, not type, but I forget what field it is. A lot of properties in Plotly. Sorry, a moment, I will remember. The main type, color, hover label. No, it's wrong. Okay, don't remember. I don't know. Marker text. We need to marker. We need to change a type of markers for this. What happens? Type inference problem. Okay, it's the end of the day for me as well, so it doesn't really matter. For example, we can provide some additional information here. For like, we want to configure additional configuration like color, string, and we want to put it here. Like this. I've changed the API, and I can create different ways of drawing. Or I do not want to use, now all pictures should be red. Yeah, there are. Or, for example, I do not like Plotly. you can see that all things I'm doing here is not dependent on what plotting library I use. So I can completely change and use different plotting library on different data loading library, whatever. So this is an example. I've also done a second example, which is much more open, but probably not a good idea to go to this because I am tired and you are tired, and maybe you have questions about what we're doing right now. Or you have ideas how to do that better. No ideas. Okay. So maybe then we should end this for today, and you can write in the Telegram if you have some ideas or questions later, and we can discuss it in offline mode. In this case, the AP is returned type, right? Well, I'm not sure I understand the question. The thing is that we defined the structure. We are not providing a function which gives you the final result, the plot. We understand that the data we produced here will be used in different ways. For example, it could be used to produce those standard deviations and plots as well. So if you are sure that you will never need this structure for anything but plots, and all the plots will be in the same framework and it will never change, it's okay. You can return the plot immediately. But if you understand that there could be possible other usages, then this intermediate structure is important. And then you design your API, you design it around the type which is used to hold your data. So you create from one side, you create the function that generates this type of data. From the other side, you create a function that consumes this type of data. And in this case, this type is the API boundary I was talking about. It's what you communicate, what different parts of program communicate with. Yeah. And again, it's very simple example, but it's an example how you can think when you design your program. And of course, those APIs should be clearly defined, and they be very simple as possible. Otherwise, it will break. Okay, I think that's all for today. Everybody is tired.